starting with the square root function. So this is the general form, a x minus h plus k. I'm going to start by graphing the parent function. And in graphing the parent function, I'm going to start by, I'm going to make a table here. And this is x, and this is y, which is going to be given by square root of x. And when I get that, I'll complete the table. I just need convenient values. Something to remember here is that I cannot get the square root of square root of negative numbers, because they are going to give me an imaginary number which I cannot fit in my graph. So I'll start at 0. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. And I could use other numbers like 3, 5, only that they'll give me decimals, which is okay, but I'll just use perfect squares because they fit perfectly in this graph. So then I plot my points, 0, 0, then I have 1, 1, then the next one is 4, 2, and then 9, 3, which is going to be right there, and then I just connect, and that's how the parent function looks like. And from here I can look at the domain. And how do I get the domain? So the domain is going to be given by x greater or equal to 0, and the range is equal to y greater or equal to 0. Remember, when I'm looking at the domain, I'm looking at the horizontal, or like the lengthwise. I'm looking at the starting to the ending point. Remember, I could write this using notation form. So this is 0 to infinity. And for the range, I'm looking at the height, the y values. So starting from the lowest point. The lowest point here is 0, and it's included to infinity. Okay, so that's the parent function. Now all I'm going to do is to transform the parent function. So these are the equations I have here. I start with the parent function. So it's 0, 0, 1, 1, 4, 2, and 9, 3. So I connect the points. So that's the parent function. Then here I can see h is equals to positive 4. So I'm just going to graph number 1 by moving it 4 units to the right. So 4 units to the right. So I take every point, move it 4 units to the right. So this is going to be right there. The next one is going to be over here. 1, 2, 3, 4. So 1, 2, 3, 4. And the other one doesn't fit. So here is my graph. And I'm going to write it here. So this is square root of x minus 4. And this is my parent function. And then let me graph the other one. The other one is going to be x plus 4. So here h is negative 4. So I'm going to move every point. So these points I have here, I'll move them to the left 4 units. So to do that, so this is going to be right here. So over here, 1, 2, 3, 4, right there. And then 1, 2, 3, 4. And I just need to combine to connect them. And this graph is going to be y is equals to square root x plus 4. That's my graph right there. So those are the transformation, and you can see the h transforms the graph horizontally. Okay, we got the next one. Now we're going to look at the effect of k. So again, I'm going to start with the parent function. And this is 0, 0, 1, 1. And then 4, 2, and 9, 3. So I connect y is equals to square root of x. And all I need to do is to graph the transformations. Plus 3, number 1, so k is 3, so I move every point 3 units up. So right there, over here, 3 units up. So then connect the points. So this is y is equals to square root of x plus 3. And now I'm going to graph the next one. So k here is negative 3. So 1, 2, 3. And 1, 2, 3. And 1, 2, 3. So that's how the graph is going to look like. Y is equals to square root of x minus 3. Okay, so the next one, and the next one here, I'm going to do combined form. And again, I'm going to start with my parent function. So 0, 0, then 4, 2, and then 1, 1, then 9, 3. So that's the parent function. Now I need to move every point according to value of h. So this is negative 4, k is negative 3. So every point is going to move to the left 4 units and 3 units down. So 1, 2, 3. So right there. And then 1, 2, 3, 4. So right there. So then the next one is 1, 2, 3, 4, 1, 2, 3. So right there. And then 1, 2, 3, 4, 1, 2, 3. Okay, so the graph is going to be right there. That's a new graph. So this is the parent, y is equals to square root of x. And this is y is equals to square root of x plus 4 minus 3. And here I'm going to talk about the domain. See the domain of the function, the translated function. So the domain is going to be from negative. And maybe here, let me talk about what we need, something which can really help you in finding the domain. So the domain, when if A is positive, actually it doesn't matter whether A is positive or not for the domain. So the domain is going to be given, by x greater or equal to the h value, or h to infinity. So in this case, the domain is going to be from negative 4 to infinity. And let's talk about the range. The range depends on whether there is a reflection over the x-axis. So for the range, and I'm talking about the range of the translated function, it's always going to be given by, when A is greater than 0, then the range is going to be y greater or equal to k. So, or k to infinity. However, when A is less than 0, the graph is deflected over the y-axis. So the range becomes the range becomes y is less than k, or we could write y from, or we can write k to from, or we can write negative infinity to k. And for this particular graph, the range is going to be from k, what's the k value? Because a is greater than 0, k is a negative 3. So negative 3 to infinity. Okay. So now here we have the vertical stretch. So again, I start with the parent function. So 0, 0, 1, 1, 4, 2, and 9, 3. So connect. And this is y is equals to square root of x. Then when I do the transformation for number 1, I'm multiplying every value by 2. So 0 times 2 is 2. 1 times 2, we get 2. And this becomes 4. This becomes 6. So the function is going to be right there. That's vertical stretch. Y is equals to 2 square root of x. And then for the vertical shrink, it's going to be multiplied by 1/2. So this is going to be halfway right there. And then 1, 2, so you do 1.5. So it's going to be right there. So that's y is equals to half square root of x. Remember, this is vertical shrink. This is vertical shrink. This is vertical stretch. Okay, here, reflection over the x-axis. Again, I'm going to start with the parent. Okay, so this is going to be, that's the parent function. I did not do it very accurately. And then then I'm just going to reflect these points across the x-axis. So 1, 2, 1, 2, 3. So, and this is how the graph is going to be. So here, this is y is equals to square root of x. And this is y is equals to negative square root of x. But while I'm still here, remember this is a reflection over the x-axis. What about if you're given y is equals to square root of negative x? Remember here, we shall be reflecting every x value across the y-axis, so multiplying it by negative 1, 2, 3, 4, 1, 2, 3, 4, and then this is going to be 1, 2, 3, and then you just connect the points. So that's how the graph is going to look like. And you can see there's a graph y is equals to square root of negative x. And you can see this is a reflection over the y-axis. Over y-axis. Here we do the cube root function. And cube root functions are a little different. So let me make a table for the parent. So this is x, this is y, which is given by cube root of x. So I start with cube root of negative 8, negative 2, negative 1, which is negative 1, 0, 0, 1, 1, and 8 gives me 2. Again, I could use a calculator and use any other number, but I'll just use these ones. Okay, so now 0, 0, 1, 1, then 8. So the next point is negative 1, 1. So this is 8. 2, and 8, negative 2. So now I connect my points. See, that's how a cube root function looks like. So that's the parent function. And you can see definitely it's different from the square root function. And you can see the domain for this one. The domain is all real numbers from negative infinity to infinity. For the range, you can see it's the same thing. Negative infinity to infinity. What did I do? I did it opposite. So here, negative infinity to infinity. And we can do transformation of this function by considering our second example. So here we are supposed to move it according to h and k. H is negative 3, k is negative 2. So I'm just going to move the values according to those values. So 1, 2, 3, then 2 down. 1, 2, 3, 2 down. 1, 2, 3, 2 down. Then 1, 2, 3, 2 down. Oh, I already do that point. Okay, and then the other point is 1, 2, 3, 2 down. And then all I need to do is to connect those points. And that will be the transformed function. And that's going to be y is equals to cube root of x plus 3 minus 2. And you can see the domain and range are the same.